Okay, in this video, we're going to be addressing all of the problems that involve simple interest. So that would be 27 through 31. And so we need to utilize the simple interest formula. And so we've got to kind of recognize that it's important to write down your formula and make sure you remember what all the components are. So A was our future amount, P is our present, R stands for the rate, which we need to make sure we remember to change into a decimal. And then of course T is in years. So let's get started on this first problem. What is the interest on $3,000 invested at 5% simple interest for 8 years? Now if you notice there is no I, so you do have to remember that your future amount minus your present will equal interest. And we'll see that a little bit clearer as we finish this problem. So let's go ahead and try to find the future because we're given the present of 3,000. We need the future 1 plus, we have the rate of 0.05 times the 8 years, and now it's basically just a calculator problem. So you're going to put that in your calculator, and you will get, let me see if I have it. Almost there. I'd put it in my calculator a few minutes ago. Okay. So I put it in my calculator and I get 4,200. So my future amount is 4,200. So this is how much I'll get in the future if I invest $3,000. So the interest would be the subtraction of the 42 minus the 3,000, and you get $1,200 is the interest. So hope that helps. Let's move on to the next problem, number 28. This one's going to be kind of interesting. I think I'm going to try to cover up this paper so that we don't have any confusion or don't get distracted with that because I want to use the same paper. So 28 has the same kind of language. So 28 on the review says, how long will it take $1,400 to grow to $1,568 if you invest at 1.5% simple interest? And so let's put those components. So the future would be the 1,568 is equal to 1,400 parenthesis, 1,400, too many zeros, that would have caused some problems. 1 plus the rate is 1.5%, but we need to change that to a decimal, so it's 0.015 times a quantity of years was what we were looking for. We're looking for T. And so here you want to do the distributive property. So we have 1568 equals 1400 because that's what it is times 1 plus we need to figure out, okay, what is 1400 times 0.015, and we get 21, so that'd be plus 21T. Now we're going to subtract 1400 from both sides. We get 168 equals 21T, and then we divide both sides by 21. Remember, we're looking for years, so 168 divided by 21, it gives me T is 8 years for my money to grow to become $1,568 if I invest today at a simple interest rate. So let's go ahead and knock out 29, same kind of language here. How long, 29, what is the total amount that must be paid back for a loan of $6,400 at 11% for 13 weeks? So again, using the same formula, notice I'm putting that every time. So my future amount was how much must be paid back. So that would be my future amount. My principal would be the original loan was $6,400. 1 plus I have a rate of 11%. And for 13 weeks, now remember time is always in years, and so 13 weeks would be times 13 over 52. And so now it just becomes a calculator problem, and leave it as a fraction, that's okay. And so we would put it in. Let's see, how do we put this in? So we have, let me clear it out so there's no distractions. We have 6400, open parenthesis, 1 plus 0.11, open parenthesis, 13 divided by 52, close that parenthesis and close the bigger parenthesis, and we get A equals 6576. So this would be the amount I would have to pay back after 13 weeks at that particular interest rate. And so again, if you're looking for how much interest is that, you would subtract the future from the present to get your answer. So now let's knock out 30. 30 is not so much about plugging in, it's more of, do you know how to rearrange an equation? So that is simple interest, it's just they distributed the P across the parentheses. And so here the first part, part A, is asking you to solve for R. And I'll try to use different colors so you can follow along. Again, I'm going to cover up this work. Solve for R. So that's who I'm trying to get all by itself. So I know that I can subtract the P. So let me come over here. I'm going to A equals P plus, I'm just writing it over again. I'm going to subtract the P, so that gives me A minus P equals PRT. Again, don't lose focus. I am getting closer to getting all by himself. I notice that they're all being joined together with multiplication. So what's the opposite of multiplication? Would be division. So if I just divide both sides by PT, that would cancel the P and the T, and that leaves me with R is equal to A minus P over P times T. We've seen something similar to these. They're called literal equations. Let's go ahead and tackle B. So B says you take that same formula, A equals P plus PRT, but in this case it wants me to solve for P. This one's a smidge more complicated because notice I have P in multiple problems. That's not inappropriate, but we have this letter P and this letter P. So we have two of them. So this does come with somewhat of a prerequisite that you may not necessarily know about, and it's factoring, and we'll see more factoring as the semester progresses. Ultimately what you say is, hey, if you see it in multiple terms, you're allowed to put that outside of parentheses. It's almost the reverse of it is the reverse of the distributive property. The P must have been distributed to both of these terms. So P times what would have given me P? It would have just been 1. P times what would have given me PRT? So it must have been the R and the T. So now I have just the letter P one time joined together with multiplication. So what's the opposite of multiplication? Is division. So I can just divide it by that whole thing. And these cancel out, and I'm left with A equals 1 plus RT equals 2P, and that's my answer. So the last one is 31, and it talks about simple interest again. So let me go ahead and start a whole fresh paper, and then I'll read the problem for you. So here is 31, still involving simple interest, would be A, P1 plus RT. And let's read over the details together. It says 31, Joan's mother loans her $570 for 10 months. If she repays the loan with a check for $679.25, what annual simple interest did she get charged? So we're looking for the rate, we have the future and the present value, and we have the time. So we have everything that we need. So the future amount that she paid back was $679.25. Her present value, loaned her $570. 1 plus, we're looking for the R, and it says, you got to pay really close attention, 10 months. Now remember, that's out of years, so that would be 10 months out of 12 months. So it's a fraction of a year. And so now, I know that we have conflicting units, so we have decimals here and we have fractions here, which can seem a little kind of wacky. And so if this comes out to be a clean fraction, then that, a clean decimal, that may be worth going here when we have conflicting units like that. But it turns out it's a reoccurring decimal, so that may not be the way to go. So let's see if we can turn this into 679 1/4 equals, and let's distribute this. So that's 570 plus, let's do, how do we do that in the calculator? 570 is going to get multiplied to 10 over 12. If you reduce that fraction, that's not bad. And so that's 475. Oh, I didn't realize it would be so clean. So let's leave this guy, the quarter. That would be R. Let's leave it 0.25. Okay, so now let's subtract 570 from both sides. So we have 679.25 minus 570, and you get 109.25 equals 475R. Divide both sides by 475, and so divided by 475, and I get 0.23 equals R, but this is a rate, and it's looking for it as a percentage, so we need to convert that to 23% is the interest rate. Hope that helps you with the simple interest formulas, problem 27 through 31.